I think the most surprising thing is the problem-based learning. My PhD is in science education. I have a master's in organic chemistry and a PhD in science ed specifically because I wanted to focus on research and teaching. And so when I got my PhD in science ed, it was very eye-opening because I was among people that were K through 12 educators. And I saw problem-based learning, and I had gotten a grant for one of my classes from Science for Society and the Public, and they gave us a training on problem-based learning, and the training was all about high school science. And I was like, no, no, we could do this in college. We could totally do this in college. So let me just tweak it for the adults in the room now to still be able to engage in the same way that they've been trying to engage with science since they were firstborn. I know in my organic chemistry class, I have so many different majors, right? I have chemistry majors, I have biochemistry, I have biology, I have engineering, I have kinesiology who probably wants to get pre-med. And so how do I create an assignment that puts them and their future actions into the material? And that's exactly what problem-based learning was supposed to be. It's a type of homework assignment where you are acting like your future self wants to be in industry, right? So whether it's food chemistry, environmental chemistry, drug design chemistry, whatever it is, we're going to try to create an assignment specifically regarding what's happening in the world around this topic and how you can see your knowledge from even week one of organic chemistry adds to that discussion. And I was so surprised that they actually felt like I was taking them seriously. They were like, oh, this was a complex question, but we approached it together in a little community. And I think at first I was worried that they were going to try to get every answer correct, but then they slowly started realizing that some things were subjective and that there was more of a social nuance with these questions. And they realized that the goal was for them to see the real life connections and just talk about them. And so I think when they started having fun with those and no one complained about them, I was like, win, 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 win for everyone. I wanted to then emphasize the importance of this group work after the first problem-based learning that they saw and just trying to get the collaboration on the tough questions that maybe did have one answer. And then when I throw in a social question, like we talk about acid and base chemistry, and we look at the basis of opioids and how do opioids work in the body? And then I throw a question like, hey, how can we make this base more stable, less reactive, so that it doesn't have to be given to a patient with a high amount or quantity, and therefore it will be less addictive because it will be active only in the site that it needs, where there's acidosis in our body. And then I follow it up with a question that's more socially nuanced, like, hey, how much would you charge for this? You're going to go out and be chemists later, right? Or doctors, and you're going to have patients that don't have equal access to medication. What should we do as a society? And there's no right or wrong answer there. I'm just trying to get them to engage with the fact that everything they're learning out in our society has a price tag now. And do we want that price tag, or are we thinking about some social programs that might be helpful, right? And you as a chemist have the power to enact those by communicating science effectively with society, by being able to vote, by being able to read about social problems in the framing of a scientist. And so I was really excited when they wanted to answer those more socially nuanced questions. They actually enjoy them. When I get my reviews back, they're always like, problem-based learning was awesome. And I'm like, okay. Like, whereas something was so daunting to me, like, this is different than anything they've probably ever experienced in OCHEM if they have taken it a different place. And this technique is for high school students. I really wanted to see in my own experience if we could bridge this gap between college and problem-based learning. And I'm really, really excited to say that that was a surprising positive outcome. There are so many people in my department that are extremely good at teaching chemistry. I have been a faculty member as a non-tenure track faculty member at numerous institutions across the West Coast. And I can tell you here, when I started working at Western 3 years ago, I have never seen a department as nerdy as I am about teaching chemistry. Everyone brings such a unique way of teaching and really puts the student first. So the ability for me to be creative and bring my own ideas was the easiest to do here and so much fun because we get to talk about it and people actually want to talk about it in my department. So I think what already was happening here just really made me feel at home in this department and in this major. Um, I remember coming to Western and I met with a few faculty members across multiple departments in the university, and I asked them specifically, um, how does someone here stay at Western? How do they get tenure? What is the goal? Every single one of them said, well, you need to teach well. And I said, what does that mean? And they're like, well, you need to be student focused. You need to be doing active learning and being creative in the classroom. You're not the one that's just dumping knowledge into their brains because that's not how people learn. And so daunting for somebody who's like, oh my gosh, everyone here teaches so well. I need to make sure I'm still up on my game. But then when you get here, it's just like, oh, we're just a bunch of teaching nerds. Like, we just love talking about chemistry and we love trying new things, and everyone is so supportive. So I'm really happy that I get to bring my ideas because problem-based learning was one that isn't super prevalent in higher education. And so being able to talk about those things with people, it's like, oh, that is a good idea. That's cool. I'm doing case studies over here and I'm doing, active learning over here. I love seeing how we all get to the same place of student agency, but with our own special flair and what makes us feel comfortable. And it helps really bring down that barrier of anxiety of, does this activity work? And we get to try it out and talk to each other about it. So I hope my work has made a slight positive impact of an already really positive department and program. It's just really awesome to be a part of chemistry here as we are all focused on that science education piece of environments and student agency within our classrooms to bring out, the best in our university, which is awesome.